Good evening, Professor. My name is Ziling, and I am a computer science student at NTU CCDS. So today, I will be presenting my final report for my 10-week professional attachment at ST Engineering Info Security. I work there as a cyber range software engineer. So over the next few minutes, I'm going to share the main project that I work on, the technical problems I face, and the solutions that I helped to build. So this was my first internship. So I will also share how much I learned from transitioning from a university assignments to a real enterprise environment. So to start, let me briefly introduce the company. ST Engineering Info Security is a division of the ST Engineering Group. So they focus on protecting critical information infrastructure in Singapore for both the public and the private sectors. So because they work in the cybersecurity domain, having technical expertise and proven capability are very important to stand out from the other competitors. So during my time there, I work in a developer team that follows the agile software development methodology. This meant that our work was broken down into sprint cycles. And also, we had daily stand-up meetings every morning to share our progress and solve the problems collaboratively. So, the main project that I was assigned to is the Cyber Range Portal. So, what is Cyber Range Portal? It is a web-based platform that is designed to simulate realistic cyber attack scenarios in a safe and isolated environment. It allows the organizations to train for cyber threats without putting their actual system at risk. My primary goal was to gain exposure to real-world software engineering practices by helping to enhance this platform. Up until this internship, my experiences came purely from my university coursework, like the software engineering project. So while that was a great learning experience, it was a much smaller scale system with a simplified architecture. So working on the Cyber Range Portal was my first time dealing with a large and enterprise level deployment. So when I first joined this project, the platform was still under development. I noticed some significant operational bottlenecks in how the architecture was set up. So firstly, the data management lacked a dynamic backend. So there are some application data that was managed using hard-coded resources within the front end. So specifically, threat actors' descriptions are stored directly as JSON file, and their profile image are also kept in the application's static folder. This meant that adding or updating the basic threat actor information will force the developers to manually modify the front-end source code and also trigger a full deployment of the application. So from a software engineering perspective, this tight coupling will cause the system rigid and difficult to maintain. So this highlights the urgent need for a more dynamic and API-driven approach. Secondly, because the platform consisted of multiple microservices, several workflows had been built independently and they are not fully integrated. So an example was that the platform's communication to Zulip. So originally, it relied entirely on its own original login mechanisms, which is Zulip login. So to provide a seamless user experience, this needs to be unified with Keycloak through a single sign-on, which is a SSO process. However, because the multi-service architecture, implementing this is not just a simple connection. So like it requires resolving complex proxy routing and authentication configuration issues across the internal network before the integration could work. So to solve these limitations, I focus heavily on the back-end and front-end development and system integration within a Node.js-based architecture deployed on a Dockerized internal infrastructure. So drawing my background in scoping database structures and designing APIs for the previous campus, monitoring applications for my other project, which is cloud computing, I was responsible for the 5 main deliverables over the 10 week. So firstly, I built a threat actor repository module with a full CRUD functionality, migrating away from the static front-end files to back-end APIs connected to a proper database schema. Secondly, I created a during action report, so which automatically generates structured PDF reports summarizing the exercise events. Next, I integrated a chat platform called Zulip with a single sign-on system called Keycloak to provide the seamless login experience that I mentioned earlier. So in my next one is I implemented a role-based access control system to define strict access policies so that the red, blue, and white teams can only see the data and features that are appropriate for their operational roles. Finally, I helped to develop a telemetry scoring system that uses periodic back-end API updates to track and calculate the real performance during the cyber exercise. So now, let's look a bit closer at my first major task, which is the threat actor repository. So as I mentioned earlier, the old way relied on the hard-coded static files. So to fix this, I applied the modular system design principles that I learned in school. So I replaced the static approach by building back-end RESTful APIs that connect directly to a database schema. So for the profile images, I stored them in a system called min.io instead of keeping them in the application static folder. The result was a huge improvement in maintainability. Then now the team can also dynamically retrieve and update the hacker profile without ever needing to redeploy the front-end code. So now moving on to the challenges that I faced. My first big hurdle was with the DAR module. So which automatically it generates the PDF reports. However, during development, I ran into a very irritating issue where like the generated PDFs are coming out like completely empty, even though the data inputs are correct. So I had to isolate the rendering pipeline step by step to figure out what went wrong. So eventually I found the root cause, where it was the environment-specific dependency issue. So the original code assumed that it was running on a macOS compatible Chromium setup, which caused it to fail on Windows, which is the operating system that I'm using. So I resolved this by modifying the code so that both the Windows and macOS can run the rendering successfully. So another major challenge that happened when I was integrating the Keycloak single sign-on system with Zulip. So like out of nowhere, the authentication request starts failing intermittently with a 500 internal server error. So to figure out what went wrong, I use a tool called Postman to isolate the API behavior. So like I carefully trace through the server proxy and authentication logs according to the documentation that the Zulip they give. So like eventually I discovered that it was a proxy routing misconfiguration that was dropping the authentication requests between the services. So these experiences taught me a very important lesson, which is to carefully to trace a lot of logs. So while my school projects taught me the foundational steps to debugging, this type of enterprise system requires much more investigation across the multiple services. So now looking back at these challenges, especially during my own onboarding, I wanted to provide a recommendation that can maybe add value. They can add value to the company's workflow. So right now, navigating the complex multi-service architecture has a very steep learning curve for new developers. So a lot of the time is spent just tracing code to understand how the system works. So to address this, I recommend that the team can develop a comprehensive architecture documentation, like an extensive README file or a internal developer wiki. So like this will include the step-by-step local environment configurations, the common debugging solutions, Then this documentation will help to allow the new developers to be able to contribute earlier and and they can work more productively. And this can also help to significantly decrease the mentorship overhead that is currently placed on the seniors developers. So through this internship, my technical skills grew a lot, particularly in understanding the scale of enterprises, environments. So in our university labs, we usually build or modify the isolated systems. So for example, handling process management and system calls within a controlled environment like the XV6 kernel in the module of operating system is challenging, but it remains as a self-contained exercise. So this project highlights the big differences that when we move to an enterprise architecture that requires a lot of coordination across the multiple interconnected microservices. So I gained a practical exposure to the back-end development, designing RESTful APIs, and orchestrating containerized environments using Docker. So additionally, working on the SSO integration with Keycloak and implementing RBAC features demonstrated exactly how critical security principles are in real-world systems to strictly enforce multi-tenant access control. So beyond the technical skills, I also experienced growth in other areas. So at the start of my internship, my instinct when I faced errors or bugs was to treat them like the university assignments. So I will just spend like hours trying to read through the documentations and trying to solve them completely on my own. So over time, I realized this was not efficient in an enterprise setting because there was actually a lot of other people that I could approach to, but I did not. So I adopted a structured approach called time boxing. So I will set a strict time limit for myself to debug. And if in the end, eventually, I still cannot isolate the root cause and solve the bugs, such as the proxy routing misconfiguration that I mentioned earlier, I will seek help and seek guidance from the seniors engineer. So this shift made me significantly more productive. So I also become more comfortable participating in the daily agile stand-ups, and I can openly clarify the architecture requirements and also adapting my implementations based on the constructive code reviews and team feedbacks. So in conclusion, this internship was a very fantastic experience that successfully allowed me to connect my academic knowledge to industrial application. So thank you for your time.